Good day. This is Aaron Islas for week number 6 and CSE 2 and 2. This week's question is asking how we're going to validate a binary search tree. And so basically for the beginning, what we really need to figure out is that we can't just check if a left child is less than the current node and the right child is greater than. That's the common mistake. Instead, we need to validate that every value, both in the left subtree, are less than the current node, and that all values in the right subtree are greater than the current node. And so the solution we have to get is, like we were learning this last week, is to use recursion with boundary constraints. So basically what that's going to look like is that first we have to create a recursive function that'll do three things. It'll take the current node and it will have a minimum and a maximum value that represents the valid range for that node. And so at each node, we're going to check three things. The first one is that we're going to check the current node's value and that it must be within the valid range. So it must be greater than the minimum and less than the maximum. And then step 2 is that we'll recursively validate the left subtree first. We pass the current node's value at the new maximum because everything in the left subtree must be smaller than this node, and that way the minimum stays the same. And then the third step is that recursively we'll validate the right subtree. So we'll pass the current node's value at the new minimum because everything in the right subtree must be larger than this node. And so that way the maximum stays the same. And that way, if all three conditions are satisfied at every node doing these three steps, then the tree is a valid binary search tree. And the result of that is that all the nodes will pass their validation, so that it will return true. This is a valid binary search tree. And so basically by maintaining the valid boundary at each level, we'll ensure that not just immediate children, but all descendants satisfy that same property. And that's why dynamic boundaries are crucial. They'll tighten as we traverse deeper into the tree, ensuring that the whole subtree respects the ordering. Thank you once again for the many things I've been learning this semester. I appreciate that very much.